Now the above grade structure. The above grade structure, I think I want to start with just a general shift in overall understanding of structure. Construction, building that we're used to building in our industry has always been designed structurally in a two-dimensional space, meaning that you can take a section, a slice of it, and at any given point in the structure, it'll behave the way you want it to behave at that one slice. Our wall, one of the biggest challenges that people have, and as Kurt alluded to earlier, a lot of engineers don't even want to go there because it's outside of the realm of what they understand. But when you see a thin wall system like we're talking about, the first thing you think of is that wall's going to buckle. How will that wall hold up? And the answer is that if you picture a piece of cardboard, right? A piece of cardboard is not going to hold a lot of weight if you push down on it, but if you build a shoebox out of it and put a lid on it and put some duct tape around it, you can stand on it, right? Because it's behaving as a monolithic system as opposed to just a component, right? So that's important to understand because there's a couple reasons. One is it helps us with the perception issue of, is this thing structurally sound? But it also brings us to the idea that you can't make the same decisions and changes on the system that you're used to possibly making with stick frame construction methods. We're taking advantage of the fact that the wall has interaction from partition walls and corners and roof trusses and floor trusses to make it structure. And when you cut a window opening, we don't have a header. We don't have cripples and we don't have king studs. The whole wall is a beam. The whole wall is acting that way. But to some extent, the placement of that window is really particular. So where the window is and kind of how far it is from certain walls, these are some of the rules and some of the engineering that Kirk's working through that doesn't exist today in our industry, and we're having to engineer and design those. So anytime a change is made and a movement is made to a wall, we kind of have to run it back through the design process to make sure we didn't change the way that wall is going to behave.
Just so you can add to the validity of what you said on your shoebox, I have myself videotaped standing on a taped shoebox, so just so you know, it's real science.
And on YouTube. When we're comparing it to our typical 2x4 or 2x6 framed wall, I'm also thinking about, it draws some parallels to advanced framing that some of you have probably seen, where you're pulling out any of the redundant pieces. But in order to do that, you have to understand what each piece is doing. And there's pieces in advanced framing that are part of the lateral wind resisting system that I'd be willing to bet some engineers don't even understand the role of each piece. But we've been building that way for so long that we ought to just leave it in there and not change anything is kind of the mentality. But you see opportunity like advanced framing for reducing the amount of material. This is kind of 3 steps beyond that because we're not even talking about studs anymore, but it does mean that you have to pay more attention to changes, like Steve said.
Well, I even think just from a perspective of like 2x4 versus 2x6, I think there's a lot of folks that still think we do 2x6 because that's what holds up the house. We need a thick wall to hold the house, but we've been building 2x4 walls long before that. And the
kind of counter argument to that, or the thing that goes along with that, is we've moved from 2x4 to 2x6, not because of structure, but now that we have gone 2x6, we use that 2x6 for structure. And so we can fit 3-ply headers, we can fit a lot of the framing that we get accustomed to doing, double trimmers and single kings and all of these things, that this is the way I've been doing it with 2x6 walls for at least 10 years, and if I switch back to 2x4, that's an interruption to my system. The reality is 2x4 is plenty for structural for most of the houses we build. We're accommodating for insulation, but now that we have done that, we're fitting more in the wall, and to go backwards, it does take a little bit of attention.
I was looking for these photos. We did a test, sort of a shoestring test here in the lab on a 2x6 or 2x4 wall crushing versus a single OSB panel. I was trying to find the pictures of it, but I can't find them. But we have both empirical testing that's been done in terms of its strength and its ability, and we also have the sort of the math that
One other analogy we've used is Monocoque Construction, so you think of the old days when cars had beams and things were built off of a structural set of components.
Frame, yeah.
Frame, were changed out, especially like race cars, where the shell is the structure, or like an airplane. So it's all done with this thin wall components, but it's done in a very particular way to give it strength beyond what you might think.
So we'll then jump over sort of the panels and kind of the idea of where the panel comes from and what is the panel. So as you guys know, it's OSB, oriented strand board, and where the panel idea came from was that at some point Pat and Tom had been looking at OSB and the idea that when they make OSB, it's pressed on a table, on a press that's huge, and it's 24 feet long by 8 feet wide. And as that thing rolls off the table, 20 feet later, it gets buzzed up into 4x8 sheets and then stacked and shipped out. And so the idea was, well, what if we would take that panel right off before it got cut and take the whole thing and utilize the entire panel as a piece of building component. And so 8 foot by 24 foot is not anything magic other than that's just how it's produced. I think if we had our choice, we would have different dimensions, but that's just what it's produced at. This particular OSB that we're using right now is made by a company called Huber, and Huber has some very well-designed recipes for how they put together the OSB. They have a product that a lot of our industry is familiar with called Advantech. Advantech is marketed as a somewhat waterproof subfloor material. They'll actually guarantee exposure on that product for 500 days in terms of its structural behavior. The way they can get that done is that they have a higher grade wood that they use in the construction, and they have a high MDO content in the resin. Okay, so it's mostly plastic, right? And so what that allows us to do is to have an OSB product where we can make things like tables and briefcases. These are things that Tom has made in the past, just to demonstrate sort of the difference between what this is and what most people's concept of OSB or particle board is. Here's a bathroom sink or a pedestal sink that is used. This is actually from Huber's facility, where they have furniture, shelving, and cabinets, and a kitchen, everything all made out of OSB. And as most of you guys have probably seen on our website, we utilize the subfloor as a finished floor by sanding and polyurethaning that, as well as countertops. We use window cutouts to make a countertop out of it. And the countertop is, so I can get a picture here. The countertop, the grain on it is so tight. So here you can see this is the countertop and the floors. Jump on over here.
That mouse works pretty good. So.
I know, it's terrible. Well, thought I had an edge picture that would demonstrate that. There it is. So if you can kind of see the grain structure of this. And why I bring that up, why it's important, is because this actually, we can generate a pull-out number for an edge screw into the edge of that, which is not something you would expect even out of just regular plywood. So we don't really rely on that for any of our structural connections, but you can make attachments through the end of that in a very robust way where you typically would think that if I drove a fastener into that edge, it would blow up. It would just sort of split out, and it doesn't. It's a really unique product. So
Does the Advantech have greater resistance to flexing than a typical OSB?
Yeah.
Because it needs things
Yeah.
of
yeah, there's this really good sort of shoestring video I saw on Facebook or on YouTube of somebody sort of demonstrating the different qualities of OSB out there. And they had it's like they're in a shop and they laid out 4x8 sheets of 5 different brands. You know, it's Norbord and GP and then the Advantech, and he goes to the first one and jumps on it, and snaps, and goes to the next one.
It was tilted up, right?
Yeah, like on a,
One
like,
end was
like
up.
one end was on a table and one end was on the ground. And did that, it broke all 4 of them, got to the Advantech, and it just bounced, right? So it has we know empirically greater structural values. We don't have testing, material testing for it. This is one of the things that we're trying to get out of this research is we don't have a modulus of elasticity for this product. We have to extrapolate from some other source. We have to create our own. I mean, Kirk and I we have a series of tests that we're going to go in the backyard and literally just build them and hit it with a car and pull it with a come along, you know, try to make things break so we can get values for them. But that's part of the research that we're doing. So as a result, the structure is I don't want to say this in the sense that we haven't thought about it, but it's over-engineered. It's stronger than it needs to be, just because we don't have those values. So we have to look at it in these very two-dimensional ways, and we're not fully utilizing the three-dimensional analysis that this system is actually capable of giving us.
The inch and eighth flooring is rated for 4-foot span.
Sure.
Yeah, I mean, there's the characteristics that they publish for structure is for use in a horizontal, and you're loading it kind of out of plane. It's nothing that you stack up and put an axial load on and push it, you know, that way. There's nothing published there. So we have to extrapolate from one orientation to the other.
Right.
But it's pretty clear. I mean, in some ways, this thing is twice as strong as a competing OSB that's inch and an eighth.
Yeah. So that's the other thing is the panel thickness we're using is a product that they're already making that gets used for a rim board. Okay. So we're using a product that's inch and an eighth thick, which kind of seems like an odd number, and I would agree with you, it's odd. But inch and eighth thick. The panel is 860 pounds each panel. So if you think about that in terms of lifting that panel, it's a pretty substantial weight. And we're taking these panels and we are we're laminating them, two of them together. Okay.
So the original product where this came from was basically truck beds, flooring for trucks
Was it mobile homes?
and mobile homes too, but it originally was developed specifically for a truck bed liner that could be retrofitted in later, put in as new. So it just tells you a little bit about its strength and its durability. You know,
Yeah.
it was a very hopped up formula for that purpose now.
It just so happened that I watched How's It Made last night, and it was truck beds. They didn't use inch and an eighth.
They didn't use insurance.
3/4. They currently, the product that we're buying from the manufacturer, they make runs for the mobile home market. So it's the floor for a mobile home structure. So, yeah.
I was wondering if there's anything from an IAQ standpoint related to the adhesive that's used to create the...
It just so happens that the person that did that research on one of our houses right here. You want to talk about it though?
So they use an MDI formula as opposed to a formaldehyde, urea formaldehyde formula. So the MDI, not that it doesn't have its own set of